here with Matt and Don, the founder and CEO of Emergent 3D in California. They just finished the first permitted 3D printed building in this state, which is an incredible accomplishment here. Congratulations, guys.
Thank you.
And now we're going to have a podcast episode and discuss the project we saw yesterday, hopefully the print we'll see today. Before we get into that, I'd really like to thank you guys for letting me stop by and film this project. One of the early YouTube videos about it, so that's really cool for me.
Appreciate you coming out.
Yeah, we're glad to have you.
Yeah, sure.
Yeah, so when you first came up with the idea as the founder, what was that like for you, and how did you then bring Don onto the process?
Yeah, so actually I've been watching YouTube, so thank you and encouragement to you and others that are, it was early days though.
Yeah, I think we were both talking about how we saw like the $10,000 printed house video. It sparked some interest.
That's right, and not being a heavily technology guy, that blew my mind. That you can print a house using an upscale, upgraded, large 3D printer to do a house, and so I was intrigued and started doing the research. And then as I went further in my research, I recognized 3D printing is an exponential technology. So this, what is in rudimentary form now, is going to just start growing in capability, capacity year on year. And so sure enough, that's what happened. And actually my family and I moved here to Redding, California 2 weeks before our nationally declared disaster, the car fire. Yeah. And I had been watching this technology, and we had moved here with the intent to start this company. What I didn't know was Emergent 3D at that point, but then the car fire happened, and so I ended up getting hired for the FEMA-funded disaster case management program that was serving the 300 families here that were uninsured or severely underinsured, and being a part of our recovery effort. And that's where Don and I met, and I was heading up the disaster case management subcommittee, and Don, as a part of this recovery team, he was heading up the construction committee. And through our community working together, I realized, we're not going to be able to recover in the way that we had hoped. And Don certainly could speak more to where the labor force here and all that was, but having an ability to make a fire resistant, the recovery effort be accelerated, and the construction side, all of those things, I realized, this could be a really practical, good solution for our recovery effort. And that's really out of the ashes, as it were, that Emergent 3D was born from the car fire. Yeah.
I was at your house, Don, last night for dinner, which was great, and you showed me your backyard, which is where the fire tornado drove through, and I guess that's what motivated you to join the recovery committee. I'm surprised you guys didn't go with the name like Phoenix or something.
Yeah.
So it really hits close to home for you guys, being impacted by fires, and you have a history of working in nonprofit and how would you say?
Yeah, as a humanitarian. So we were serving in conflict areas in the Middle East, and before I was married in Sudan when they were having the genocide that was happening there. And so and that is the ethos of our company, is to help people in need, and specifically within housing. Because we have I know it's across the country, but here in California, the housing crisis is very acute. But then you layer on top of that our national disasters that are happening. 3 months after our car fire, the Camp Fire happened, and where we lost around 1,100 homes, they lost 14,000 homes. The whole town was wiped from the map, and so that is another area that we're actively helping to with the recovery effort there, bringing housing solutions.
So before you met Don, you were interested in the 3D printing thing, and you hadn't ordered a printer yet?
That's right. No, it was just still in the research phase, and
you knew you needed someone with construction experience.
Absolutely, yeah. And so and at that point, everybody was kind of thinking I was watching too much of the Jeffersons or of Star Wars or Star Trek, but started visiting with one of my buddies, and I said, "Hey, this is what I want to do, and this is the opportunity here." So he was the early angel investor, and so then engaged a friend of mine who is a world-class architect. Told him about it, and he said, "How did you know about this before I did?" And so brought him on board, and then our structural engineer, and then we just started working at designing a 3D printed house. Obviously, because I was new to California and not being heavily into construction, didn't realize the high bar for the construction. The codes here, it's one of the toughest in I think all 50 states. And so we were actually starting to go down one track, and then I started going researching all the top 3D printer manufacturers in Europe, and then when visited Kobad, it quickly became apparent that they were the forerunners, and that was early days. That was 2018, 2019. 2019, I think is when I went out and did that trip, and so that's when I decided to start focusing on Kobad, and then they actually, because they had the first 3D printed house in Europe, were able to give us insight on how they did it and brought it back to our structural engineer and architect, and that ultimately is, and very much with Don's involvement, and we can get into that, those three together, the architect, structural engineer, and Don, being able to find a way through the existing code, but even then, it was still a heavy lift to get that figured out.
There's a lot of stars that need to align for a printed house to be built, especially permitted in a residential populated region. You mentioned the architect and structural engineer. Two more that are kind of on Don's side, maybe you can kind of walk us through, is the municipal relationship and the labor unions you have on board too.
Yeah, that's for sure. You talk about the stars aligning. There needed to be a bunch of those, and so those are two other factors. As Matt said, I've lived here in the Shasta County area now for about 32 years, and so I know a lot of people within the community. A lot of people in the community know me, and so after we had our car fire, again, as Matt said, that's where we met, because I was asked if I would serve on that long-term recovery committee that FEMA had established, running the construction subcommittee portion of it. And so it was through relationship with the folks in our municipalities that I was even asked to serve there. My willingness to do that, I think, became maybe even part of the catalyst that got them excited when 2 years later we approached them about this idea of 3D printing, right? So in our case, we've always felt it's really important to build good partnerships, good relationships, and it has served us well in doing that. And so now an extension of that is with LIUNA, our union labor force. Every one of our field workers are represented by LIUNA, and that was absolutely by design. It's an easy narrative for somebody to tell that the robots are stealing our jobs, and we wanted to address that head on. And LIUNA was so forward thinking when we approached them that they said, we see this as the future as well. It might take some time, and it will, to really gain some momentum, but they see this as the future, and they came up on board with us, with both feet. They jumped in. Yeah. So we're really thankful for that relationship. It has already been paying off, and we see really bigger dividends in the future as they develop training centers. They're talking even national training centers for 3D printing, because as this thing grows and spreads, it would be really nice to be able to make a phone call and get fully trained 3D print employees, which right now are non-existent.
Yeah, you mentioned you guys have national growth ambitions, and to achieve that, construction historically hasn't been very scalable, but you were mentioning 3D printing is exponential, which is the most scalable almost you can be. So having access to a workforce in that region that knows how to operate the printer, the 3 to 6 guys you need, is instrumental to being able to print there. and you're talking about the future benefits of the union. So the guys there now, how are they going to train, or how big is the union? What's that going to look like moving forward as it evolves?
So to speak to the size of the union, I'm not positive numbers wise, to be honest, but they are a national organization. Some of the stories we heard directly from them was, for example, after the disaster of 9/11, LIUNA was called to come up with the safety protocols for digging through the rubble of the towers, for example. Mm. They are involved at that level nationally, right? And so that confirmed to us when they were telling us those kind of stories that we partnered with the right team.
So they're very procedural, I guess, and they have a history of educating the newer union members so that they're prepared when they reach the site.
Very much so. They're very safety oriented, obviously. They are all about the employees, which in our case, prior to even thinking about the thought of joining a union for our company, we knew that we wanted to pay well. One of the stories I tell, and I'm not ashamed to say it, it's just the economics of it all. I've been a builder for many, many years, and the homes that we've built over the years, the very guys and girls working on those homes could not afford to buy those homes. If we can up the wage, we can up the benefits, if we can pay a better living wage and remain competitive because we have this technology that allows us to do so, and perhaps at some point, not yet, there's no $10,000 printed homes yet, I get that, but at some point when we can start realizing some cost savings, then maybe we can flip that script, and maybe the very people building the homes can buy the homes as well, and that would be a dream come true for me.
Yeah, certainly. It's cool to see you get involved in the community and you give back, and then it kind of comes back for you. You were pointing out some of the houses you built in the community, so you build those relationships and then it improves your business. I guess you're a strong believer that you do good in the world, and that's a good, like, money isn't always made by evil or like doing mean things. Sometimes you could do good things and get a return.
You know, so Matt was mentioning the car fire that we had, and that's what you're referring to. That's the service we were doing as our community was recovering. Me and my family, we had to evacuate our home. The fire NATO, I remember when I got home that evening, I could hear all the helicopters and I could hear sirens in the distance, but the fire was on the other side of the Sacramento River, and I thought, what a great fire break. I mean, we should be good. We've got this perfect fire break.
Makes sense.
Next thing I know, the police are driving through our neighborhood telling us, get out and get out now. We throw a bunch of stuff in the truck, and I remember distinctly, I could no longer hear the helicopters or the sirens. I couldn't hear any of that. I just heard the roar of this fire NATO. As we were driving away and I see that in my rearview mirror, I remember the anxiety inside of me, like, oh my gosh, like, what am I going to do tomorrow? Where are we going to live? What about my house? And I'm a builder, and I'm wondering, I have anxiety, like, oh my gosh, like a bunch of us are going to need homes, us too. I'm already thinking, where am I going to live tomorrow? Come to find out that many of my friends, many of my acquaintances took comfort. It's all right, I know Don. I know a builder, he'll rebuild. And I wouldn't dare let them know the anxiety I had, much less, that they were putting their trust in me. And so I remember driving away after I found out, actually I didn't find out for another 3 days that our home was spared. The fire did come to our back fence, but thankfully somehow it didn't burn the house down. I realized, as we were talking about trying to help these 300 people, or 1,100 some people lost their homes. I remember thinking, A, it could have been me. B, it could have been one of my family. I've got children here and grandkids. It could have been one of my family. It was some of my friends, right? Like, this touched us all. And as a community, I knew we had to rally together. One of the things I used to tell people, a couple of things. One is that the cavalry is not coming. Shasta County was only one place that we had a fire disaster. And quite frankly, if somebody was going to travel from elsewhere to come help us rebuild, they wouldn't come to Shasta County. They'd go to a more affluent area if they're going to live out of a suitcase. Sure enough, the cavalry didn't come. We were on our own to rebuild our community, and we're good with that. But it took all of us to rally together to do it, you know. So it was that was the heart of what got us together. Quite frankly, is we still want to rebuild in disaster-struck areas. Disaster recovery is a big part of what we want to do. Workforce housing, like we touched on earlier, is a big part of what we want to do. And then we've just got this crazy homelessness issue that there is no single answer, and this isn't a single answer either. There's pallet shelters, and there's all kinds of other things. There's mental health issues. We get it. There's all of that. But a factor is a roof over somebody's head.
Yeah.
We can certainly be a part of that. And so with LIUNA, we're in the state of California, love it or hate it, California will spend money on solving those problems. And that's what we're here for. We want to be a part of that solution.
Yeah, I think it's important to have your contractor experience in this emerging field. A lot of people, they buy the printer and they're expecting a product that's like a MacBook or a microphone where you turn it on and it works like it's expected all the time.
Right.
But there's so many more steps for the printer, and it's a skill to operate, sometimes an art more than a science. And so facing those challenges and overcoming them requires kind of like the old school street smarts of a contractor, it seems like. Are there any examples of things you've had to combat? I'm sure there's some maybe you'd like to keep to yourself, but any you can discuss.
Oh gosh, I mean, there's probably hundreds of them, really. So one of the contingencies I never planned for was the equipment, quite frankly. There isn't a lot I can do. I mean, I'm hoping the equipment works as advertised, and for the most part it does, but there are 1,000 things that can go wrong with a 3D printer system and the material delivery system. There are connections everywhere. There's all kinds of issues, and any one of those can shut you down for the day. So we do the best we can there, and we have generally been pretty successful with it. We've got a good support team from COBOD that helps us out if and when there are issues that come up. But then printing is only 10%? Printing those walls is maybe 10% of building that house. You still now have a house to finish, and every single trade is a little bit different. Mm-hmm. Every little issue is different, and quite frankly, we're still dealing with people who have real life issues. And if somebody who is not in the trades think they can just hit a button and build a house, you still have roof trusses. So you still have carpenters that have to come in. And that one carpenter had a fight with his wife, and so he didn't show up to work, or any other issues. There are 1,000 different things that you have to work out just in construction in general, much less the specific differences of this type of construction. So we are, in a lot of ways, inventing an industry with every day that we are in this business right now.
In my experience, construction doesn't have always the best communication. Sometimes the drywall guy goes over the sockets before the electric's in, or the drywall guy spackles over the socket or something. How do you increase the communication on the job site in a situation where they're encountering things for the first time they've never seen before, and you want them to explore their own creativity in finding solutions?
Yeah, so one nice thing is that this is exciting and new, so we've got their attention. A lot of the subs, if they're just used to doing the same old thing, then you're right. They don't really, their head's not in it. They got their earbuds on and they're doing what they're doing. But this is new and exciting, and we've got their attention. So that definitely helps. Secondly, and it's part of Emergent 3D's business model, right now, the work we're doing in Shasta County and the surrounding areas, we are also in control of the general contracting of it. However, when we work outside of this area, we want to work with a local general contractor. We will be their 3D printing sub, but we'll work with one of their locals so that they can bring their trusted subs and suppliers that they're in relationship with, and then we will educate them to come along. So again, the beauty of it is that people are fully engaged because it's so new and fresh, and they see an exciting future. So that part of it really helps.
I think there's a lot of general contractors out there eager to get involved with this technology, and if you, as a subcontractor operating the printers, enable that for them, I think people would be very interested in that. What's the time frame that you'll have the capacity to do that?
We're there now, and so we had a successful seed round this summer, and so we're poised to scale. We know that we're going to scale. We're starting here locally, but we have inquiries from across the country and even internationally. So and that's what we say to general contractors. We've already figured out. We've already done the heavy lifting. We got the team of experts. Let us serve you well, and then we can accelerate the whole process overall. If they want to get into it, they're going to have to go through, honestly, I don't know what we say, 2 years of heavy lifting.
Yeah.
It isn't, like you said, not just pushing the space bar. There's so much that goes into it, and so but we've already cleared the path in that regard, and so we're there now, and we want to get homes built, so 3D printed.
That 2-year time frame, is that for permitting purposes, or is that for the educational purposes? How are you making that estimate?
All of the above. So here in California, I mean, that obviously, in order to get through the building code, that took us a dedicated year of the experts really banging away at it, and so it would be easier in other states that don't have to deal with the seismic or the as high of an energy requirement, etc. But to get your team together, to get the infrastructure together, to figure out really what you're doing, to get everything really dialed in, I think that's fair. 2 years, what you say?
Absolutely, yeah. The learning curve is pretty steep even before you get started. You know, even the first model home plan that our architect designed, it was done before I was even on board. We look at that now and realize that's really not 3D printable. You know, that's not something that we can actually produce. We have to make some changes, and so even he had a learning curve, and then on top of that, you got to figure out, you know, how am I going to pay for that machine? When will that machine pay for itself? But if there's a contractor or developer out there that just wants to get into the industry and they don't want the huge capital investment and they don't want the long learning curve of coming up to speed, and they figure, you know, I can build a house, I just don't know all of that voodoo, that I feel like that's where we can come in. And it becomes a win-win, quite frankly. We can bring this technology all over.
Yeah, absolutely. It's really interesting, the time differences between people expect they get a printer, they might print 52 houses their first year, by the second year comes around, maybe they have 3 more printers. They have that expectation, but that's not really the reality when it comes down to it. Let's say permitting was handled and you get the printer delivered day 0. How many days until is the education completed before the printer arrives, or does it all have to happen hands-on?
Can you clarify? I'm not.
So with permitting out of the way,
We're ready to build, right? We're ready to build. So generally what we've been doing with our first homes is that we're doing a semi-conventional slab on grade foundation, and then the printing happens after that. So assuming that happens, again, once permitting happens, you can go to work as soon as you go to work, get the underground utilities in, get the slab poured, and we come set up. Our setup's going to take a handful of days. So if we're talking an experienced crew like what we have now, setup's going to take a few days, and depending on the size of the house, the current 1,200 square foot house that we have permitted and designed, if we have 4 good print days, we can get it done. We have yet to have 4 good print days in a row, but we'll get there, and we're learning. I make no bones about that, and you know, we're working bugs out. But 4 good print days and we can do that, and then it's a few days to tear down and remobilize. If it's a new crew coming up to speed, I can tell you that when we took delivery of our equipment, our manufacturer sent a team, Cobot sent a team out here to train us on site. And they trained us for 2 solid weeks, and that's what they call their level 2 training. Level 1 training happened online, and that was a week's worth of training online. So there was quite a learning curve. And quite frankly, even before that, we were paying for our team to go work on the crews of other 3D printers in different parts of the country just to gain some real world experience, if possible. And it all helped.
Can you say which printers they worked on?
Which company? Which
Sure.
manufacturer, you mean?
Either.
So they were, in both cases where we sent them, they were Cobot. They were Cobot printers. And then the company, one of them was We Print Homes down in Arizona, and the other was Nidus 3D up in Canada. They were both welcoming. I mean, the flip side is we covered their costs. They got some free labor out of the deal, but I thought, what a great trade.
Yeah, I think that's smart.
It's a great trade. We got some good education out of the deal. So I'm very thankful for both those companies.
Yeah. How is the network effect with the Cobot community? There's so many different people with Cobot printers. Are you guys tight knit?
I think so. It feels like Cobot is really encouraging that even more and more nowadays.
Yeah.
So yeah, I feel like it is.
I guess it's been a small group. I know from experience with like online groups, when they're small in the beginning, it's not super active all the time, but as it grows, it's more and more useful. And I guess it's just tricky. You guys work so hard to figure out the best solutions for things. It's kind of your competitive advantage at some point. So every company has something they want to kind of keep to themselves. And
That's fair. And that's really true.
and it's not wrong either. It's just the way business is. You don't want to give away all your competitive secrets, but at the same time, there's some stuff that's low-hanging fruit that ideally could be shared.
That's right. Yeah. There are some of those kinds of things. With a simple site visit, they're going to see it. So what's the big mystery, right? So, but I would agree. There are certain things I'm sure everybody keeps a little closer to the chest.
To illuminate some of the R&D challenges, can we talk about the hose management system?
Sure.
What's that been like?
So when we first ordered our machine, so we're talking specifically Cobot. When we first ordered our machine, basically the hose management system was the hose going up and over a pulley. And when I first saw that in action, it was in Virginia about a year ago with Alquist 3D. And they literally had to have somebody on the back end of that hose either pulling it by hand to take up the slack, or they tied a rope to it with a bobcat and they were driving back and forth.
Yeah, that guy wasn't my size. He was like probably 6'6".
That's right.
Bear hugging the hose. I mean, it's a 3-inch diameter hose, 60 feet long, maybe filled with concrete.
Concrete. Yes. And you had to keep that you couldn't let all that loop just hang out in your print area because it's going to interfere with your print. So that was hose management, version 1. When we placed our order, they had developed what they called their version 2 hose management system, which when they described it to me, I thought was genius. And I actually visited Denmark. I visited their plant in December of last year, and I saw it sitting in the corner, and I said, "Oh, can I take a picture?" And they said, "No, we don't. We'd rather you don't, because we don't have it all patented. We don't have it all worked out yet." So, but I checked it out. Really cool. I thought whoever invented that's a genius. Not only the hardware, the software, and the way it was going to work, I thought that is incredible. By the time we were ready to take delivery, they invented the next level, what they're calling their advanced hose management system, which is what we ended up getting. We never even got version 2. We upgraded to version 3 now, and that's what was delivered, and that's what the Cobot team came and installed on our machine. And we used it fully in its fully designed state on our first print. The one challenge I have with it is that it introduces so much more hose length. And as you know, one of the things you want to do is move material through the hose. You want to get it from pump to extruded as quickly as you can. You just want to keep it moving. The less hose, the better. And so it introduced, because it's running all the way down your y-axis and then all the way down and back on your x-axis. So we did it. We had issues probably like everybody does. We had a clog here and there every now and again, and we'd have to deal with it. And we had, probably 200 feet of hose to manage during those challenges. Now we are simply bypassing the advanced hose management system on the y-axis. We are still using it on X because it's great. Like it really works very well. We're just not having it run through the entire y-axis anymore. We're leaving a coil on the ground, and because of the way our house is designed, we're not traveling that far along the y-axis. Our house is designed such that we have these full height openings, so we can print from 0 to 8 feet before we even start the other side. So our travel along the Y is fairly limited. So we can just leave a little coil there and have it just get into the x-axis. And we've eliminated somewhere, I think, 60 or 80 feet of hose, which is huge in our part. So I really like the concept. And there will be times that we have to use the entire hose management system. This modified idea won't work on some designs or on bigger prints, but it was a nice idea for us to make the modification for this house, that's for sure.
Do you know when you'll get the second printer?
For us, it is once we have enough homes under contract to trigger number 2, and so we are our pipeline is filling up quickly, and so we're on the cusp of that. But that's why number 1 was so important, is everybody wanted the proof of concept to see, and the conversations that we've been in with, developers or housing nonprofits or municipalities. Everybody was kind of waiting to see, can it be done? Is this science fiction or is this science fact? And now that we're past that milestone that it's science fact, then the larger contracts will come in, and then we'll start getting additional printers.
But those bigger developments to your point, they take time to come to market,
right,
to be ready to go, and certainly we've had, since we finished printing our first home, we've clearly had an uptick on our website, on our social media, clearly. But hey, that's really cool. Translating to a shovel-ready project, that's a very big leap. And so, to Matt's point, it's project driven. We've got our funding mechanism in place. Literally, the day that we have a volume that justifies it, we'll order our second printer. Or geography, that could be another thing.
Yeah.
We're looking at places, as Matt said, all over the country. And so it won't make sense to transport our printer when we've got jobs to do right here, and we've got a few to do elsewhere in the state or in the country, and it's far enough away. It would just make more sense to hire and train a crew there and just start growing from there as well.
Yeah, I get a lot of people reaching out to me about they want a 3D printed house. It's hard fielding requests like that because out of 1,000 of them, 5 have realistic expectations.
Yeah. One of the things that one of our filters, I guess I'd say, is if the conversation is cost driven, then we know we're probably not going to make a connection, because to your point, there is no $10,000 printed house, right? I think that bubble's been burst. What we're telling people is there will be cost savings when we get really good at it, when we can start even 3D printing the foundation and do some other things. We'll find ways. There will be some money saved. When we print a wall, if we're not putting extra finishes, exterior, interior, we will save money. It'll come. We're not there. So if cost is your factor, then we're probably not your solution. Our big sell is design, right? My entire career has been straight, square, and plumb. If it's not straight, square, and plumb, you've done something wrong. Now with 3D printing, if all you're doing is straight, square, and plumb, you're doing something wrong. It trips me out that people are doing 3D printing, and when you drive by, you would never know because it's straight, square, and plumb. I love that we can do curves and bevels and angles and things that would have been so incredibly cost prohibitive before. That's where I could tell people, okay, yeah, you could save money. Try building this shaped house with sticks and mortar, right? I guarantee I could print that house cheaper. But if we're talking square, it's just not an apples for apples comparison. And that's what we're trying to let people know is, please let your imagination run wild about what we can do. Like we can do curves that were never possible before. We could do shapes that never existed in architecture without really just spending an absolute fortune.
Yeah, definitely. All technologies are expensive in the beginning, and especially you're certainly early adopters. If there's something before that, I don't know, you'd be in that category even potentially, but almost developers. Like, you guys are changing the way that technology is implemented.
Yeah.
So, yeah, it's a big deal. And I think being the first permitted home in California in such a tough state to get permits gives you a monopoly on for the time being. So anybody who wants to print a home in California basically has nowhere else to go until somebody else wins a permit on a house.
Yeah.
How does the inspection process for that home differ from a traditionally built home?
So it's a great question. There again, relationship helps a ton, because our head building official asked me the same question. Don, when are our triggers for inspections? When do we come inspect? Like with conventional construction, it's obvious. We know you come at these certain milestones. And I said, Jeremy, I don't know. I said, how about for now, you just said we'll call for an inspection every single day. Just come see what we're doing, and we will together work out the milestones. Because truly, I don't know right now. But we'll put our heads together and do it. And again, there was enough relationship, enough trust, and quite frankly, that wasn't a bad idea.
Yeah.
Right? Why don't we just do that, and we'll come up with it? And so that's what we're doing. And so we don't have it figured out yet. We're still doing daily inspections.
You keep your job sites pretty organized. Some contractors, the inspector every day would be a nightmare, but
Yeah.
that was smart. And I think that the inspector was probably scratching his head thinking the same thing, like, how is this going to go?
Yeah. I'll take the risk. We got assigned a fairly young inspector, and so there's a lot of things and he's being extremely careful. There's a part of that being careful that I actually kind of like. When we were getting our plan checked, it went through 5 different structural engineers, and it went back and forth 4 times before we got that permit. As a builder who ultimately, it's our responsibility, like our liabilities on the line for these things, not even necessarily the city who permitted that thing, it's us. So there's a part of that careful that I really like. Our inspector is no different. So we're having to walk him through things that perhaps we had conversations with the head building official about, but we're walking him through it, and we're getting through it, and he's learning just like the rest of us are, quite frankly.
Yeah, I mean, once you wrap your head around the vertical columns that are traditionally poured with rebar, it's not like the building will come, it's not dependent on the material that's printed to be structural for the roof. So if there was a crack or failure in the material, it would be non-structural.
That's right. Yeah, but still, and we had to do on our first one here in Reading, we had to do a test to test the strength of the bond between layers, and specifically for the section of wall in between those columns. The idea being, hey, if the wind blows hard enough, or if you're in a tornado and a 2x4 comes launching at it, what's it going to take to break that wall, right? They wanted to test the bond between layers. And so that was something that we had to prove to them, even on the non-structural components, I guess you could say. And so while Cobot and their training team were here, they were doing some test prints, and they printed these things that I could best describe as these maybe like pots, like flower pots. They were just a diameter that they printed these things up. And after it was done, we moved them off site, and they were sitting over there, and just to check it out, one of our employees, I wanted to see, what does it look like if you break this? So he took a sledgehammer and he went to break it. It took him 3 or 4 hits, number one, to even break that chunk off. And I wish I had a picture of it. But from the outside and from the inside, you could see the stratified layers. Like, clearly you could see that this was 3D printed. But when you look at that broken edge that was created by the break, it absolutely looked like one piece. It looked like it was something that was poured in place. You didn't see any lines. And I thought, oh my gosh, our little bonding test is going to pass with flying colors. And sure enough, it did. It acted like one piece. they test those things to the point of failure, and the failure didn't happen at a splice. It just happened probably at the point of greatest pressure, quite frankly.
Yeah, monolithic concrete is important for the permitting, and some people do a whole monolithic house structure, but with your designs, you've printed in multiple different elements.
Yep.
How did you come to that decision?
So part of it was I wanted as few cold joints as possible.
Mm-hmm.
And so we can't quite print one element in a single day. We're going to have a cold joint, but the fewer the better. So the fact that we have these opposing full height openings means I could drop my x-axis down and do it that way. And so where possible, we want to try and continue to design that way, but it's not always guaranteed. Design won't always allow for it. But that was really the driving factor, is the fewer the cold joints, the better. Also, it helps with alignment issues the next day. If I don't have to slight alignment adjustment issues, again, down the road, I don't want to ever know that, oh yeah, that was the end of day one and the start of day two. The more we can avoid that, the better.
Yeah, the cold joint thing is something a lot of people overlook. I think after you finish a day of printing, you need a layer of dual bond epoxy before the next concrete, so that you get something monolithic. The epoxy bonds it to the next layers.
Yep.
The epoxy is not cheap. I looked on Amazon. A 5-gallon bucket is like $1,500 or something like that. So how much cost does it add each? Or another way to ask it is, how much are you saving if you can avoid a cold joint per cold joint?
No, that's absolutely right. And to be very honest with you, I'm a little less concerned right now about our cost.
Yeah.
I want to prove that we can build these things. And we got through our first one and we're starting our second one. I am a little less concerned, but you're exactly right. Like, if I can use half as much on a job because we're doing full height prints or half height prints every day, then it does save us. One of the things that we're looking at is, so our print head, and I actually have a printed sample of
one here too.
Yeah. So generally our print head is, it's extruding a layer that is 2 inches wide. And after we get up off the slab, we're installing our side trowels on it, and we're running it through, and certainly it's extruding at 2 inches. But by the time we're said and done, by the time we're layering up, we probably end up at closer to 2.5 inches, just because of a little bit of slump, a little bit of this and that. So one of the changes we made, and so what that did, it created some rough openings that were a little too tight for doors and windows. The voids that we left in between some of our narrower walls got actually a little too tight in some cases. So we learned from it, and we created a new flap for ours, a new side trowels that actually encroach into the openings. So now we are technically just printing 1.75 inches wide, but by the time it's done, it's going to end up 2 inches plus anyway. But if you think about it, when you talk about cost savings, that just saved us 12.5% on our material, because now we're extruding it 1.75 inches instead of 2 inches, right? So there are, just like the exponential technology, there's going to be some big swings in savings, in design. There's going to be some big swings, and that's really, quite honestly, part of the fun of all this, is that we get to be a part of those big swings.
Yeah, there's so many facets that need improvement. So I guess at this early stage, you're not really zoning it. There's so many tiny little ones. You're focused on the big picture and working towards all the intricacies, which is promising towards the future of the industry, I think.
Yeah.
So you mentioned another printer. Your logo features a robotic arm printer. Are you committed to Cobot for the second printer, or would you shop around?
So our tagline is that we're implementing tomorrow's construction technology. So our end goal in Emergent 3D is to get homes built and printed right now. The more, as we're the early adopter and we're printing in concrete. When I was doing my research and saw that they were 3D printing in human tissue, I realized, okay, the construction industry and the application of this technology to construction is going to only accelerate all the faster. if NASA is, and Elon Musk and the others are looking to fully automate and send autonomous 3D printing and construction robots to the moon or to Mars, we have a long way to go yet. And so but we need families and homes now. I think the stat is over 1 billion people in our world are underhoused in some way. That shouldn't happen in the 21st century with technology like this available to us. Construction is the last industry to be massively disrupted by exponential technologies. It's here, it's coming, it's going to continue to accelerate. And so we right now are using the Cobot 3D printer, but we are going to be implementing as the builder all these new technologies, because then that